In this video, we're going to talk about set builder notation so that you can understand all of the symbols and numbers and things. So this is an example of set builder notation, and it describes a set. So it says the set A is going to contain all of these different things. So it's the set of all x's such that x is an integer between -2 and 4, including -2 and 4. So as we break it down into its parts, here's the x. This little bar means such that. Then we describe all of the values. So x such that x is between -2 and 4. And it's inclusive because those are less than or equal to signs. And we know that x comes from the set of integers. So therefore, we've limited our set to only including whole numbers, so we don't have to worry about fractions or decimals. If we wanted to list all of those values on a number line, we could, because it's a finite set, and it would just be the whole numbers between -2 and 4 inclusive. So that's how they put a dot at -2, -1, 0, 1, 2, 3, 4. If we wanted to know how many elements are in that set, we would just count those values and recall this notation. So the number of things in set A is equal to 7 because there were 1, 2, 3, 4, 5, 6, 7 numbers on that set. If you have an infinite set, that means that you're probably taking from the set of real numbers or the set of rational numbers, which means that there's sort of an infinite number of numbers between the numbers. So when you're graphing, if you had to do that, it would be these lines that shade in all of those values, not just a single point. So let's do this first example here. Suppose A is equal to, and then it gives you set builder notation. And the first question is to write down the meaning of the set builder notation. So we know that we're talking about x such that x is an integer between 3 and 10, including 10. So we had x such that x is an integer between 3 and 10, including 10. For part B, if we want to list the numbers, well, it doesn't include 3, so we would start at 3, but we don't include it. So what's the next integer? It's 4. And then 5, 6, 7, 8, 9, and we do include 10. So this is the set of A if we were listing it all out. And for part C, we want to know how many are in that set. So we just count them up. 1, 2, 3, 4, 5, 6, 7. So we would know the number of elements in set A is equal to 7. When you're working with set builder notation, it's pretty important that you know and understand the vocabulary that they're talking about. So here's some crucial vocab, and the stuff that we learned in our first lesson is actually really helpful too. But you need to know what an integer is. You need to know what a real number, a natural number, a rational number is. And these ones, I know that you know them, but you just have to think about if it says it's the set of odd numbers, then we're talking about like 1, 3, 5, 7, 9, etc. If it says it's the set of even numbers, 2, 4, 6, 8, etc. Recall that prime numbers does not include 1. So for prime numbers, it's going to be like 2, 3, 5, 7. Then we skip to 11 and on like that. So make sure that you understand that vocabulary.